Okay, dear students, we'll be studying about physical properties of alkenes. Physical properties of alkenes. From carbon number 2 to carbon number 4 begins from ethene, right? So carbon number 2 to carbon number 4 they are colorless. They are colorless, odorless gases. Colorless, odorless gases. C2 to C4 are the colorless, odorless gases. C5 to C17, they are colorless liquids. They are colorless liquids. And C18 onwards, C18 onwards, alkenes are solids. Alkenes are solids. Physical property and how they exist. C2 to C4 are colorless, odorless gases, and C5 to C17 are the colorless liquids, and C18 onwards they are solids. Next, chemical reactions. Chemical reactions of alkenes. Chemical reactions of alkenes. First one, addition of dihydrogen. Addition of dihydrogen. Addition of dihydrogen. So alkenes add one molecule of H2, one molecule of hydrogen gas in presence of platinum, nickel or palladium catalyst. Palladium catalyst. Then with platinum and palladium is okay, and the nickel means all these what we are using, platinum, palladium and nickel catalyst are finely divided. Finely divided means we make into a powder, or the surface will be providing more surface area. When we make it powder, will be provide more surface area. Finely divided nickel, platinum or palladium, we can get alkenes. We can get alkenes. Double bonded. When we add hydrogens to a double bonded, obviously what happened? Then it becomes single bond. Double bonded compound into single bond. Alkenes add one molecule of hydrogen. This is alkene. To this, when we add hydrogen gas H2 in presence of platinum, palladium or nickel, what we heard of hydrogenation. One hydrogen add here and one more hydrogen add up here. So we'll be getting CH3 and CH3, that is alkane. First one is addition of dihydrogen. Second one, in chemical reaction of alkene, addition of halogen. Addition of halogen. Addition of halogens. First one, halogens like bromine or chlorine add to alkene to form vicinal dihalide. Earlier, just now, we discussed about vicinal dihalide and geminal dihalide. So, halogens like chlorine or bromine add to alkene to form vicinal dihalide. Then what happened? The reddish orange color of the bromine solution in carbon tetrachloride is discharged bromine added to the unsaturated side. So if we say in words, so it's not good. So instead of writing, I'll write an equation. So this is H, this is H, and this is H. That is an alkene. To alkene, we need to add halogen of Br2, bromine. Bromine in presence of CCl4, carbon tetrachloride. So that is brownish red bromine. This is ethylene, is nothing but ethene. Ethylene is nothing but ethene. So this will be bromine. Bromine, so that is brownish, BROW, NiSH, brownish red color. So what happened? So we'll be getting the colorless solution. Ethane is colorless. When we add this hydrogen, bromine will add to the adjacent to the adjacent carbon vicinal dihalide. We'll be getting vicinal dihalide. This carbon with single bonded carbon, and one is bromine here, and this bromine attaches to here. The rest will be hydrogen, hydrogen, and here hydrogen, and here hydrogen. Then what is the name of this compound? 1, 2. 1, 2 is ethene. So 1, 2 dibromoethane. 1, 2 dibromoethane. Reddish brown color discharges will be getting the colorless solution. Colorless solution. What it is? That is ethane. 1, 2 dibromoethane. So addition of halogen. Similarly, for the unsaturated compound, this also we can do test for unsaturation. This also we call as test for unsaturation. We can do test for unsaturation. SATURATION, test for unsaturation. Instead of this, in the same compound, okay, are propene, CH3. C hydrogen, double bonded carbon with that hydrogen and hydrogen. Treat with chlorine. So we'll be getting, so adjacent, chlorine attaches to these two carbon. One chlorine attaches here, one chlorine attaches here. We'll be getting carbon and carbon. Chlorine get attaches to this chlorine. Hydrogen, hydrogen, hydrogen and hydrogen. We'll be getting 1, 2 dichloro. 1, 2 dichloropropane. We'll be getting 1, 2 dichloropropane. First one is addition of dihydrogen, next addition of halogen. In this addition of halogen alkene, so electrophilic addition. This is an electrophilic addition reaction. What happens? This electrophilic addition, what we saw, this is an seal negative group where it attaches to. So carbon, where the density is less. So the addition of hydrogen halide. Here hydrogen or hydrogen halide. One is hydrogen halide. We can take together addition of H and hydrogen with any halogen. So this will be possible. So this is addition of halogen to alkene is example for electrophilic addition. Electrophilic, PHILIC, electrophilic addition reaction. So iodine does not show addition reaction under normal condition. Iodine will not show addition reaction under normal condition and bulk here. Okay, next up. First is addition of hydrogen. Next is addition of halogen. We combine together addition of hydrogen and halide. Addition of hydrogen and halide is called as hydrogen halides. Addition of halogen acids or hydrogen halides. Halogen acids is nothing but HCl, HBr, HI or etc. No, halogen acids is also called as hydrogen halides. In that, the order of reactivity in hydrogen halide, HI is greater than HBr is greater than HCl. Like addition of halogen in alkene. So addition of hydrogen means hydrohalides is also the same. There is also an example for electrophilic addition. There is also an example for electrophilic addition. So in that addition of any halogen like NHCl or HBr or HI. So how it will be adds. So addition, alkane, carbon, carbon, double bond. So electrophilic addition in that hydrogen, here hydrogen and here hydrogen. So halogen acid is added to the electrophilic addition. Symmetrical alkene. This should be a symmetrical alkene. So what happens when we add plus HBr, hydrogen bromide. Hydrogen bromide, H and Br. H plus and Br minus. So what will happen? So it will form an Br. No? This hydrogen adds to the double bonded compound. If hydrogen adds to double bonded compound, then what happens? A free radical that will be on the Br minus. It forms a Br minus. When hydrogen adds to here, this becomes carbon, is hydrogen. If hydrogen adds to this H plus, because an electron density more here, carbon-carbon double bond. Now it is carbon-carbon single bond, and this carbon with hydrogen and hydrogen. So what happened? This creates a positive charge, carbocation. Creates carbocation. Now Br is having dot, no, means negative charge. Electron will be shifting here. This Br minus attacks to the positive, means the positive charge. Here Br minus will attack. Br minus. So just a minute. So Br minus, this Br minus attacks to carbocation. If attacks to carbocation, this is first step. Step 1. In second step, step 2, this attacks to this carbon, hydrogen. This carbon, hydrogen. Br attached to here, this Br. So with this is what butene. Then we'll be getting 2 bromo, 1 2 1 2. So or the substituted, sorry, this butane, 1 2 carbon number. So 1 bromo 1 2 ethane. So this is 1 2, that is not butane, that is ethene. From that we'll be getting 2 bromo ethane. Are you getting? So symmetrical alkene, addition of HBr to the symmetrical alkene means equally. If it is unsymmetrical alkene, we'll be getting major and minor product. So in symmetrical alkene, we are getting like this. Another example. CH3, CH double bond, CH3. 1, 2, 3, 4. So butene, butene. This will be addition with HBr, hydrogen bromide. So hydrogen, where the hydrogen needs to add, hydrogen adds to this H and CH becomes CH2. And here, and bromide will be attacks, Br minus will be attacks here. So we'll be getting CH3, CH2, second carbon, hydrogen, H plus H, CH2. Single bond, CH and Br attaches to here, no, CHBr and CH3. 1, 2, 3, 4, butane. Second carbon will be having the bromine, 2 bromo butane. So 2 into 2 bromo butane. 2 bromo butane will be getting the compounds like this. This is symmetrical alkenes. In unsymmetrical alkenes, addition reaction of HBr to unsymmetrical alkenes, how it will be? This is symmetrical alkenes, no? Is it clear? We'll see in unsymmetrical alkene. Unsymmetrical alkenes. In unsymmetrical alkenes, what happened? Hydrogen halides added to unsymmetrical alkene like propene, 3 carbon, no, and the propene. They will be forming the Markovnikov's addition, Markovnikov Markovnikov's addition. What is that Markovnikov's addition? What is Markovnikov's rule? So you need to remember that Markovnikov's rule states that negative part of the adding molecule, or hydrogen halide adds to the carbon which contains least number of carbon least number of carbon atoms. So you need to understand that what is the statement of the Markovnikov's addition? What is Markovnikov's rule? Negative part of the adding molecule. This is for unsymmetrical alkene. For symmetrical alkene, no problem. Equally, it will be clean. It means addition of alkene to the double bond, it will be adds. For unsymmetrical alkene, follows Markovnikov's rule. Markovnikov's rule states that negative part of the adding molecule, if you take HX, X is a negative part. If you take an HBr, Br is a negative part. Negative part of the adding molecule adds to carbon which contain least number of hydrogen atom. Least number of hydrogen atom. If we take any the substituent group where it will be attached, not least carbon, least hydrogen atom. So carbon should have a least number, less number of hydrogen. To that, the substituent group is attached. So we can notice, we can notice here. So take an example: R C double bond CH2. So what it is? Unsymmetrical alkene. R group is attached. No, so CH3 it becomes propane. Unsymmetrical alkene. For unsymmetrical alkene, addition of HX. In at HX, this hydrogen will be having partial positive charge and halogen will be having partial negative charge. Then what will happen? So which will be formed RCH, RCH, single bond CH. Hydrogen will be added where where hydrogen needs to add, where the negative part of the adding molecule adds to the carbon, consisting the less number of hydrogen. X should be attached here and hydrogen should be attached to this carbon. Are you getting? So this one, negative part of the adding molecule adds to carbon containing less number of hydrogen atoms. Here, no hydrogen atom, no. So here, if you take, we'll be getting one hydrogen atom. So the CH, so 3 bond, 1 hydrogen. Here 2 hydrogen. What happened? So CH molecule, here X, negative part will add to this hydrogen, CH and X. And CH2 plus 1 more hydrogen, CH3. So we'll be getting alkyl halide. We'll be getting alkyl halide. Okay. Or C double bond CH2. You can notice that one more example. In the case CH3, CH double bond CH2, CH3 double bond CH3, CH double bond CH2. Okay, so in this propene, So here, when you take propene, that is CH3, CH double bond. Okay, that's propene or CH2 double bond, CH2. For this, when we add HCl or HBr, hydrogen chloride or hydrogen bromide, in this negative, positive part and negative part. So what happened? This is partial positive charge hydrogen. This is partial negative charge Br minus. Then this negative part of the adding molecule adds to the least less alkylated, more alkylated or less number of hydrogen. So that should be the major product. Out of this we'll be getting the two product. One is major product, another is minor product. What is the major product? So this negative part add to this carbon, means carbon to this row, this CH3 group. Then we'll be getting CH3 CH. So here attached group, negative part of the adding molecule Br, and it becomes CH2 plus H is CH3. So this is the most stable. So this carbon is 2 degree carbon, which is more stable, Also possible, this Br minus will be attached to this more alkylated. The tendency of getting that compound is less. That is CH3 CH. For this hydrogen will add. It becomes CH2 Br. So this is 1 degree carbon. 1 degree carbon is nothing but this is less stable. 1 bromo. This is 2 bromo. No, 1 2 2 bromo 1 2 3 propane. 2 bromo propane. This is 1 bromo propane. 1 bromo propane is less stable than the 2 bromo propane. Are you getting? So more alkylated and less alkylated. You need to understand. More alkylated is one. More alkylated is one, which is having the more substituent group, the less hydrogen. Keep in mind. Okay. Less alkylated is one which is having more hydrogen and less R group. So Markovnikov's addition, you need to understand the rule, or what is Markovnikov's addition. Negative part of the adding molecule adds to carbon which contain least number of hydrogen atom. So halogen H6, will we consider hydrogen alide, hydrogen will be having partial positive charge and halogen will be having partial negative charge. So this is plus and this is minus. Then negative part of the adding molecule adds to the carbon containing less number of hydrogen atom. This is called Markovnikov's addition. Important, you should know, you should understand properly in addition, Markovnikov's addition. In this, we can write mechanism, no? So for this, how this major product and minor product we are getting? Simple, we can write in 2 steps, this mechanism in the 2 steps. Mechanism. So in this, the first one, step one, in the hydrogen bromide provides an electrophile. Hydrogen bromide, HBr, provides an electrophile, right? That is E plus or nothing but H plus. So HBr dissociates as H plus plus Br minus, right? This is provides an H plus. Then electrophile attacks. Second step 2. H plus electrophile attacks the double bonded to form carbon. The attacks to the double bonded carbon to give the 2 product. So propene CH3 CH double bond CH2 plus H plus electrophile, where the electrophile needs to add to the double bond, right? So we'll be getting CH3 CH CH3. Then what happened here? Charge created one addition of this hydrogen on this double bond. Then it binds with hydrogen, will be forming the carbocation. This is 2 degree carbocation. 2 degree carbocation. The same and opposite. This is more stable, no? more stable. And opposite, hydrogen can able to add to the next to that carbon. Next to that carbon is nothing but CH becomes CH2. This is CH3, CH2. If hydrogen adds here CH2, then it becomes the single bond CH2, two of hydrogen will be forming positive charge. This is 1 degree carbocation. 1 degree carbocation. This is 2 degree carbocation and this is 1 degree carbocation. 1 degree carbocation, stability of carbocation. 1 degree is less stable than 2 degree carbocation. 2 degree carbocation is more stable. Then in step 3, in 2 step, it's over. No, in 3rd step. So after the formation of carbocation in 3 degree, so secondary, so you need to be noticed here. 2 degree is most stable. Secondary carbocation is more stable than primary. Okay, so the large amount what it will be forming, so is a faster rate. Formation of the compound is faster rate in 2 degree than 1 degree. Should be clear. In step 3, secondary carbocation. Secondary carbocation is attacked by negative part of the adding molecule, here Br minus. Negative part of the adding molecule is Br minus. If Br minus attacks to this 2 degree carbocation, I'll take this one, CH3, CH3. Here is positive charge, right? To this Br minus, negative part add to this. If it add to this, will be forming CH3, CH3 and Br. This is what we are getting, the major product, 2-bromopropane. 2-bromopropane is the major product, right? Similarly, this Br minus, if these Br minus adds to the 1 degree carbocation, that is CH3, CH2 plus 1 degree carbocation. So for this 1 degree carbocation plus negative part, Br minus. If the Br minus adds to this 1 degree carbocation, we'll be getting the product like CH3, CH2, Br. This is 1 degree, 1-bromopropane. 1-bromopropane is minor product. 1-bromopropane is minor product. Are you getting? Okay, the mechanism we can write. So how we can write? With the help of Markovnikov's addition, we can able to write. And for especially for unsymmetrical alkene, negative part of the adding molecule adds to the carbon containing less number of hydrogen. It is called Markovnikov's rule or Markovnikov's addition for unsymmetrical alkene. For the symmetrical alkene, no problem. Negative part adds to the saturated hydrogen, adds to carbon bonded, and the next adjacent to that, the halogen will attaches. So unsymmetrical alkene, you need to remember this. In unsymmetrical alkene, addition of hydrogen halide in unsymmetrical alkene follows Markovnikov's addition. This follows Markovnikov's rule. Sometimes against to this is called anti-Markovnikov's addition. Sometimes against to this we call as anti-Markovnikov's addition. What is an anti-Markovnikov's addition? Anti-Markovnik, NIK apostrophe S, Markovnik, MARKONIK, Markovnikov's, KOV apostrophe S, Markovnikov's addition. Anti-Markovnikov's addition is also called as peroxide effect. Peroxide effect. When in presence of peroxide, opposite will be getting the reverse of compound. This also be called as Karsh effect. KHARASH, Karash, I'll pronounce as Karsh, KHARASH, Karsh effect. Karsh effect. Anti-Markovnikov's addition is also called as peroxide effect or Karsh effect. Okay, what is this? In presence of peroxide, addition of HBr. We'll take an example of hydrogen bromide. Two unsymmetrical alkene like propane. So it takes place opposite to Markovnikov's rule. Is nothing but negative part of the adding molecule adds to carbon containing more number of hydrogen atom. This is called anti-Markovnikov's addition, which takes place only in presence of peroxide. This also be known as Karsh effect, because it is observed by the name of scientist M.S. Karsh and F.R. Mayo. So that is a reason which also called as peroxide effect, anti-Markovnikov's addition, and the Karsh effect. So take an example of propane. CH3, CH, double bond, CH2. That is propene, right? In this propene, treat with HBr, hydrogen bromide, HBr. So in the presence of peroxide, each element will be having an equal number of oxygen peroxide. So what happened here against to that? What we expected in Markovnikov's addition will be 2-bromopropane is the major product, and the 1-bromopropane is the minor product, but it is reverse. Here in this case, we'll be getting the two compound is CH3CH in double bonded compound. Less number of hydrogen it adds. No, this is Markovnikov's addition. Okay, in CH3. So in CH3, this add to the single bond. So here what we are getting is 2-bromopropane. 1, 2, 3 propane. Second, 2-bromopropane. Propane, propane, 2-bromopropane. This is minor product. This is minor product. Why? Because against to Markovnikov's addition, anti-Markovnikov's addition. Now this is 2-degree carbocation, right? There Br minus is attached. But in 1-degree carbocation, CH3, CH2, CH2, Br. There here 1-degree carbocation CH2. For that negative part is attached. Negative part of the adding molecule adds to carbon containing more number of hydrogen. More number of hydrogen. There 1-bromopropane. This is the major product. This is the major product. So earlier what we get the minor product, that is the major product. 2-bromopropane, 2-degree carbocation is major. Now it is minor and this is major product. Are you getting? We can see the mechanism, how it will be. So in mechanism, first one, step one, peroxide effect. So this peroxide effect takes place, proceeds via free radical mechanism, free radical chain reaction, free radical mechanism. In that step one, in first step. So formation of the free radical. In that, if you take an example of the peroxide, so benzyl peroxide, specific example, the Karsh effect or anti-Markovnikov's addition, you need to remember with the specific example. C double bond O, that is C6H5, C6H5 O oxygen. And again, an opposite side, C double bond O, C6H5, C6H5O, C6H5O. This is oxygen linkage, peroxide linkage. This is called benzyl, ZOYL, benzyl peroxide. In benzyl peroxide, oxygen will be having 2, 4, 6 electron between this bond. Instead of this bond, 6 electron. Here, 2 and 4. This will be the 2 of electron. Out of this 2 electron here, so how the free radical, 1 electron moves in this side, 1 electron moves in this side. So upon heating, homolysis will take place. Homolysis, equal separation. Actually, Fishhook, if I write Fishhook, it's suitable. So homolysis will take place, will be forming C6H5, C double bond O, 2, 4 and 5. radical. C6H5 C double bond O dot benzyl radical will be forming in first step. Okay. In next step, in second step, in the next step, this formed C6H5 means radical, benzyl free radical, turns to the phenyl free radical, the same as C6H5 C double bond O and O. C6H5 C double bond O. This will be having 2, 4, 5. This is the benzoate free radical. This benzoate free radical removes COO, removes in carbon dioxide, removed as carbon dioxide, will be forming C6H5 dot plus CO2. This is called phenyl radical. Phenyl radical. What is this? This is benzoate free radical. Benzoate or benzyl or benzoate free radical. From this CO2 get eliminated, then so shifted, an electron shift to this and it will be forming phenyl radical. Next, in step 2, in first step it will be formation of phenyl radical. Second step, bromine free radical attacks alkene and generate alkyl free radical. Okay, and the secondary alkyl free radical being more stable is formed faster. Secondary free radical, primary free radical compared to the primary and secondary will be noticing now how it will be formed. See this, CH3, CH double bond CH2. So this with Br dot bromide radical Br. So this will be CH2 CH2. What we are getting in Br minus. CH2 is double bond CH2 homolysis. This is part 1, formation of phenyl radical. Next, homolysis. So Br dot H plus H dot H plus plus Br minus. Here will be forming Br dot radical. Due to homolysis, how it will be forming? This will be equally separates. Equally separates will be forming one radical on this carbon and another radical on this carbon. Understand? This is the double bond. No, one radical here, another radical here. So I can write here. If you consider this CH3, CH, C, if Br adds to the least hydrogen, means here, then a radical CH2 and free radical will be forming here. That is 1 degree free radical. This is less stable. 1 degree free radical is less stable. Why it is less stable? Okay, 1 degree free radical. And here, this CH3, CH. So if homolytically cleavage will be takes place now, if it at this side will be forming free radical, and this will be having CH2 and this is Br. So carbon attaches to two different groups. This carbon attaches to only one carbon. This is 1 degree carbocation, 1 degree radical. Here 2 degree radical. So 2 degree free radical is more stable than 1 degree. So 2 degree more stable. 2 degree free radical is more stable. So formation of radical like this, addition of negative part. CH dot and C2. Why this will be more means more stable. Third step, secondary alkyl free radical attacks another HBr. There will be HBr molecule, another HBr molecule to forms the product. Since the secondary free radical is more stable, 1 bromopropane is the major product. This addition is against to the Markovnikov's rule. CH3, CH dot, CH2, Br. To this HBr adds an HBr, so homolysis will be takes place. Homolysis will be takes place, will be forming. If homolysis will be takes place, so what where the Br should HBr negative part now. So will be adds to will be getting a product of CH3, CH2, C hydrogen adds to this CH3, Br, CH3, Br with the formation of radical. This is H plus and Br. So hydrogen adds to here. If hydrogen adds to here, what it forms is 1-bromopropane with the formation of radical Br radical. This is the major product. This is the major product. For the same thing, CH3 dot CH CH2. Here, if the group attaches to here, this one degree free radical. 1 degree free radical for the same thing is attaches to HBr. Then homolytic cleavage will take place. Hydrogen adds to radical will be forming CH3CH Br and CH3 plus Br dot. What it will be forming is minor product, MINOR, minor product. Hence, in this case, especially in the case of peroxide, that is reverse against to Markovnikov's addition. Need not to get worried why this peroxide, benzene, phenyl or radical have considered. To make the cleavage means peroxide in presence of the phenyl radical, this will be takes place against to Markovnikov's addition. Hence, it is called anti-Markovnikov's addition. Hence, it is called anti-Markovnikov's addition. You need to be clear with this, especially this way what we are studying, unsymmetrical alkene, chemical reactions of alkene. Symmetrical alkene, no problem at all. In unsymmetrical alkene, we'll be following the Markovnikov's addition. Markovnikov's addition, negative part of the adding molecule adds the carbon containing the less number of hydrogen. If it is reverse against to this, then it is called anti-Markovnikov's addition. This will be noticed in presence of peroxides. This was observed by the Karsh, hence it is also called as Karsh effect. Okay. Markovnikov's addition and anti-Markovnikov's addition. We should be clear with this. Okay. Then the products. In the case of isobutylene treated with HBr, then what are the products? In absence of peroxide, not a presence of peroxide, absence of peroxide, how you are getting CH3, CH3, double bond CH2. So this is what 2-methyl propene or isobutylene. Isobutylene or 2-methyl propene, right? 2-methyl propene treat with HBr, hydrogen bromide. So the two, presence and absence, will be getting the major product. I'll be writing only major product. If no peroxide, absence of peroxide, in presence of peroxide and absence of peroxide. If no peroxide, then what happens? So carbon, negative group attaches to here, this carbon, then we'll be getting CH3, CH3. So hydrogen adds to this and bromine will attach to here. Br will be getting tertiary butyl bromide. This is called tertiary butyl bromide. Tertiary butyl bromide is the major product, and this is Markovnikov's addition. Markovnikov's addition. Clear? In presence of peroxide, there the minor product here is major product, is nothing but here negative part of the adding molecule should adds to the more alkylated CH3 here should attaches to this. Then what happened? This becomes CH3 CH, the group is attaches to there, one hydrogen here, then it is CH3 CH2 and Br. If CH2 Br against to that anti-Markovnikov's addition, this is isobutyl bromide. Isobutyl bromide is the major product when we used peroxide. Then it is against to Markovnikov's addition. It is anti-Markovnik, MARKOV, anti-Markovnikov's addition. So presence and absence, you need to be noticed that in presence of in the presence of peroxide. In presence of peroxide, there will be anti-Marconic oxidation. In absence of peroxide is nothing but no peroxide, that is Marconic oxidation. So you should be clear about the Marconic oxidation. So in unsymmetrical alkene, chemical reactions of unsymmetrical alkene, negative part of the adding molecule adds to the carbon containing less number of hydrogen. Clear? So peroxide anti-Marconic, in absence of peroxide, Marconic oxidation should be clear. Okay, next. Addition of sulfuric acid. Next reaction, chemical reaction, addition of sulfuric acid, H2SO4. An addition of sulfuric acid. Cold concentrated sulfuric acid adds to alkene, CH2 double bond CH2, that is ethene. To that, when we add concentrated sulfuric acid, which follows Marconikov's rule, okay, then an electrophilic addition reaction will take place. This is ethene, CH2 double bond CH2, ethene. Treat with sulfuric acid. I'll write separately how it will be separated. HO, S and OH. H2, SO4, SO4, oxygen 4, S double bond O, S double bond O. So SO4 group, and this is OH. For this, we'll be getting addition. Okay, so this is O minus, which follows the electrophilic addition. Sulfate by electrophilic SO4 minus follows an electrophilic substitution. Electrophilic addition reaction will be getting CH3. Okay, CH3. This one, CH2. Are you following? This O sulfate group, SO2, that is OSO, that is OSO2 group, OH, will be adds to this, or this also can be written as C2H5, C2H5, HSO4 minus. Sulfate group is HSO4 minus. Okay, so SO4 minus to this HSO4 minus adds to this C2H5, HSO4. So this is ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Ethyl hydrogen sulfate. So again, I'll not write the same addition, Marconic oxidation. So already we explained, just you need to follow this. I'll write equation. Clear? So similarly, take an example of propene, CH3, CH double bond, CH3. In this propene, treat with sulfuric acid. We'll write HO, SO2, OH. Same thing now, HO, SO2, sulfur with oxygen, and this OH. So HO, SO2, OH. I have written in condensed form. So we'll be getting CH3, CH3, then group will be added to this OSO2 OH. So we call it as propyl hydrogen sulfate. Propyl hydrogen sulfate. So this is addition of sulfuric acid. This is addition of sulfuric acid. Are you getting? So with the H2SO4 addition, negative part of that's HSO4 minus, this negative part of the molecule adds to the least carbon consisting less number of hydrogen, follows Marconikov's addition. Okay. Next, addition of water. Addition of water. In addition of water, in the presence of the few drops of concentrated sulfuric acid, means alkene with acidified water, like few drops of water. So this alkene react with water to form alcohols. So this also follows a Marconikov's rule. Marconikov's rule. So example, CH3, C double bond CH2, and this will be CH3 group plus H2O water. Acidified. So to represent the few drops of concentrated sulfuric acid, we can write NH plus. If we can write NH plus, what happened? This methyl, no. So 2-methyl propene. 2-methyl propene. To that acidified water H plus. So carbon will be attached to this and CH3 group. 2 CH3 group. No, here one CH3 and one more CH3 group. And OH part, OH adds to this OH and it becomes CH2. Negative part, OH and H adds to this becomes CH2 and H is CH3. And OH minus adds to here. Then it will be forming C alcohol. This will be 2, 1, 2, 3. 2 methyl pro carbon single bond ane to all. 2 methyl propane to all. This also follows Markovnikov addition. Are you getting? Oxidation in alkenes and react with cold dilute aqueous solution of potassium permanganate is called Bayes reagent. Okay, so next is oxidation. Oxidation. In oxidation, alkene react with cold dilute aqueous KMNO4. Aqueous KMNO4, potassium permanganate, is called BAEYER apostrophe S. Bayes reagent. Remember, this is important. Bayes reagent. On alkenes react with Bayes reagent, which is vicinal glycol. Vicinal glycol. Glycol means 2 alcohol groups are attached to that. Okay, diols or glycol will be getting to the using of KMNO4. Then this color will be changes. Decolorization of KMNO4 will be changes. Hence, this test is also used for unsaturation. Test, this Bayes test is used for to check the organic compound unsaturation. Okay, so alkene CH2 double bond CH2 alkene. So treat with the water H2 means potassium permanganate, aqueous potassium permanganate. So potassium permanganate, which will be providing oxidation from KMNO4. What we are using? Dilute KMNO4. Okay, at 273 Kelvin. Okay, 273 Kelvin. So CH3, what happened? HOH and OH group. Now H2O can be written as HOH and oxygen will be together OH and OH. So 2 OH groups are formed now. This 2 OH group adds to the each of the carbon will be getting CH2. Then OH is attached to this carbon and the CH2 and OH is group attached to this carbon. Then what happened? Will be forming ethane. Ethane 2 carbon 1,2. 1,2 diol is also be called as glycol. Is also be called as glycol. So this is oxidation as like addition of water. Here when we use dilute aqueous potassium permanganate is called Bayes reagent, which provides an oxygen, present oxygen. Okay, this oxygen with water will forms an OH and OH. So this OH group adds to carbon will be forming glycol. Or when we using propane, we'll be getting propane 1,2 diol. The same H2O and propane will be getting 1,2 diol. Clear? In case of the acidic potassium permanganate or acidic potassium dichromate oxidizes alkene to ketone, and the acids depending upon the nature of alkene, the condition, and based on the experimental condition. So here we got an alkene. So instead of that, when we use, instead of dilute potassium permanganate, if we used acidic potassium permanganate, so methyl propene will be writing CH3 twice, C double bond CH2. So 2 that CH2 group, that is 2 methyl propene, 2 methyl propene. This will be treated with potassium permanganate KMNO4. Okay, and H plus acidic condition. So what happened? This will be CH3 twice C. Oxygen will add to this, will be forming C double bond O, CO. Okay, and the rest will be forming CO2 and H2. Rest will be forming water with oxygen, CO2 and carbon dioxide and water. So CH3 twice C double bond O is water, propene, ketone, prop 2 1 ketone will be forming. So instead of this, if we take butane, CH3 CH double bond CH CH3, that is butene. Butene and treat with acidified potassium permanganate KMNO4 in acidic condition will be forming CH3COOH, two molecules, that is ethanoic acid. Ethanoic acid. So condition in oxidation, when we use dilute KMNO4 base reagent, we'll be getting alcohol. When we use acidic KMNO4, we'll be getting ketone. So there will be difference. Potassium acidic KMNO4 will be getting ketone, and dilute potassium permanganate will be getting alcohols. Okay, that is an oxidation. So we'll be having one more the chemical equation, that is ozonolysis. Ozonolysis. Ozonolysis of alkene involves addition of ozone molecule. Addition of O3. Ozone is O3. Okay. Addition of ozone molecule to alkene. Alkene form ozonide. And then cleavage of this ozonide in presence of zinc in water to the smaller molecule. This reaction is highly helpful in detecting the position of double bond. This will be help in the detecting position of double bond. Position of double bond in alkenes or in unsaturated compound. Ozonolysis, which is used to identify the position of double bond. What is ozonolysis? Ozonolysis of alkenes involves addition of ozone molecule, addition of O3 molecule to alkene to form ozonide ring structure. To form the ozonide to the ring structure, then it will be cleaves, and it can identify the position of the double bonded compound will be forming. Okay, so we'll see an example. If we see an example like propene, propene carbon number 3, CH3, CH double bond CH2. This is propene. This propene treat with ozone O3. Then what happened? This propene I can write in with the addition of oxygen to CH3 C double bond O. Oxygen will be added to this. This added oxygen I can write here CH3 CH. Okay, for this carbon, oxygen will add now one oxygen. So 3 of oxygen, one more, and this is one more. Then this CH2 group double bond. For this oxygen, the CH2 group is attached. Clear? So here, when we add O3 molecule, this double bonded carbon, 3 oxygen molecule will be added to this, will be forming carbon with oxygen 1, carbon with oxygen 2, oxygen with oxygen is 3. This attaches to 3 carbon. So 3 oxygen to this carbon. Then this oxygen attaches to the last CH2 group. So this will be binds together, will be forming the cyclic group. This is called ozonoid. This is propene ozonide. This is called propene ozonide. It is an intermediate. Then this will be treated with zinc and water. So what happened? It cleaves as will be forming CH3 CHO. This will be cleaves as CH3CHO, which will be forming CH3CHO. This is aldehyde. Ethanol, THENAL, ethanol, and remaining is HO, CHO, the C, hydrogen and hydrogen, CHO. So with the using of zinc, will be forming HCHO. HCHO is a compound, not common compound, means the formaldehyde. Formaldehyde we call as methanol, METHANAL, methanol, THNAL, methanol. Okay, so we'll be forming of the aldehyde, means ozonolysis. When ozones are treated with alkene, will be forming ozonoid, which are treated with zinc in water, which gives aldehyde, the mixture of aldehydes. This is the common example of ozonolysis. So to detect the position of double bond where the group is attached, no, then there will be substituting group C double bond O, this one. So if you take one more example, it should be clear. So propane, carbon, double bond with CH2. So I'll write to understand like this CH3 and this will be CH3. If you write CH3, CH3, this CH2, for this will be add ozone. 1, 2, 3. That is second carbon having methyl group. 2-methyl propene. 2-methyl propene upon addition. So double bonded. Here oxygen should add no. I'll write here C. 1 CH3 here. For this, one CH3 is here, the CH3. Oxygen will be added O, oxygen and oxygen. Clear now? O3. Next, this right side CH2 group attaches to this. So this is ozonoid, O-Z-O-N-I-D, ozonoid. This will be treated with zinc with water, H2O. We'll be getting mixture of alcohol. Then we'll be getting CH3, C double bond O, CH3. This is one part. CH3, C double bond O, CH3. Left is CHO, aldehyde. We'll be getting CH3, C double bond O, CH3. This propane, E is replaced by 2-1. So prop 2-1, and with the formation of formaldehyde, HCHO. C double bond O, HCHO. Will be getting mixture of aldehydes. This is ozonolysis. Are you understanding? Addition, you need to clear that how ozonoid will be forming. So propenes means alkenes are treated with ozone. It will be forming ozonoid, which are treated with zinc in water. Zinc and water will be getting the mixture of the ketones. Mixture of ketones. Aldehyde and ketones. Will be getting aldehyde. Sometimes we'll be getting aldehyde as well as in ketone. Okay. Higher, when we go to the higher alkenes, we'll be getting ketones. Next, last one is polymerization. Polymerization. Okay. Polymerization, long chain, no? Phenomena in which simple molecule. So in polymerization, this long chain will be joined together to form long chain. In that the simple unit is called monomer, M-O-N-O-M-E-R. So monomer. Monomer is the smallest unit, small simple molecule, which is repeatedly combined together another molecule. You keep on combining, will be forming the long chain. Repeating unit combined with another repeating unit will be forming the long chain, is called polymer. Okay, that process is known as polymerization. Molecule will be combined. Example, if you consider ethene, ethene will be combined together another ethene, another ethene. Ethene is monomer. Okay, ethene is monomer. Ethene combines with C2H6. Again, ethene combines with ethene, will be forming long chain, is called polyethene. Polyethene, polypropene, polyvinyl chloride, PVC. These are all the polymers. Okay, this polyethene, especially polyethene, we call it as polyethene, or what we use the plastic bags or the transparent sheets are polythenes. What we are using are polythenes, which is obtained by the combination of large number of ethane molecule. So this is also addition. Example, carbon-carbon double bond. Now, why we are discussing polymerization? Because ethene is one of the best example, polythene. That is CH2 double bond CH2. So if it forms n number of molecules, n number, this will be at high temperature with using suitable catalyst, high temperature and pressure using the catalyst. So we'll be forming CH2 single bond CH2. So combining with a n times. This is called polyethene. So polyethene shows in polymerization by using suitable catalyst. Similarly, polypropene also. CH3 single bond CH double bond CH2. This is what polypropene. So n number of propene molecule combine together to form polypropane. This is only a propane. Propane at high temperature and pressure using suitable catalyst. So we'll be getting carbon CH. Okay, for this we'll be forming CH3. This will be branching, this shift here. So then it becomes single bond. CH2 will be N times. It will be repeating unit. Then it is called polypropene. This is called polypropene. Okay, these are the chemical reactions of alkene. So what we studied the alkene. So just now we studied the polymerization, right? Polymerization. Earlier, just before, we studied about ozonolysis, right? Next, reverse order. Okay, ozonolysis. And after that, before that, we studied addition reaction, that is oxidation, addition of oxidation. Earlier, we studied addition of water, and before that, we studied addition of sulfuric acid, right? And before that, we studied addition, unsymmetrical alkene, Marconic oxidation, anti-Marconic oxidation. Marconic oxidation and anti-Marconic oxidation. That is an unsymmetrical alkene. Before that, we studied symmetrical alkene. Okay, and before that, addition of hydrogen halide HX, addition of HX. Before halogen, before hydrogen. These are the chemical reactions what we studied in this session. Hydrogen, addition of hydrogens to alkene, addition of halogens to alkene, addition of hydrohalogens, the dehydrohalogenation or hydrogen alloy, addition of hydrogen alloy to alkene, symmetrical and unsymmetrical in that. Next, addition of sulfuric acid. Next, addition of H2O. This follows in Marconic addition. Next, oxidation, addition of oxygen using Bayer's agent KMNO4 acidic and the diluent. Next, ozonolysis. Next, polymerization. These are the chemical reactions of alkene. These are the chemical reactions of alkene. Is it clear? So in alkene, what we studied, we studied the nomenclature already. We studied the structure. We studied isomerism. Physical properties. We studied physical properties. At last, chemical properties. Okay. Next, if you are through with this, kindly go through this video. See carefully. Okay. If you are not understanding, kindly ask me. If at any point, if you're not understanding, kindly you need to ask me. The next, after this, in next session, we'll be studying about all kinds of triple bonded compounds. Okay, so we'll continue in the next session. So if you have any doubts, kindly ask me. Okay? Okay, we'll continue in the next session. Thank you.